I'm really happy to be here today and to give you a short and more or less interdisciplinary view on my research topic, on the topic of light pollution. As Tilo Hoffmann already said, I guess many of you or the majority of you already heard the word light pollution. And today I want to talk a little bit about the insights, the impacts, and so on. So let's directly start. At first, before we talk about light pollution, I want to give you a short introduction. What exactly is light? Light is a word we use in our everyday life. Every day, maybe every hour, we say the word light, put the light on, put the light off, whatsoever. But what exactly is light? Light is a part of the electromagnetic spectrum, which is in a range where we say the wavelengths are in a nanometer range. Nanometers, what exactly the thresholds are, will be discussed in the next slide. But let's stick for the moment that the visible light is in the range of nanometer wavelengths, directly between ultraviolet and infrared. And let's say you don't know really thresholds of visible light. If you don't know from where to where, from which wavelength to which wavelength does light, visible light, really go, then we have to find major aspects of what light are. And there are, in fact, three major aspects what we can see what light is. The first one is, like discussed before, light, of course, is this part of the electromagnetic spectrum visible to the human eye. So now we defined the detector of this light, of the visible light, which is in fact our human eye. The second one, and this was a discussion for a very, very long time and still is in discussion, what exactly are the thresholds of visible light? And the International Commission for Illumination, they defined the wavelength threshold to be between 380 and 780 nanometers. This is important for us because now we know from where to we have to take a closer look if we talk about light pollution, for example. And the last thing is, and this is maybe the most important thing, of course, light triggers an immediate perception to the visual system, not only for the human ones, for animals, for example, and for the environment too. This is what we are going to discuss today. But talking about the visible light, of course, we are only talking about the human visual system. And in the top right plot, you can see two curves. These two curves are very important ones if we talk about the human visual system, because these are, in fact, the sensitivities of the human eye. And here you can see that between this range of 380 and 780 nanometers, our eye does have various sensitivities. The red line is the so-called photopic vision, which we have at very high ambient light levels. So this means, for example, during the day. And the blue one is directly the opposite, the scotopic vision, so-called. This is for a very low ambient light level. So for example, going through a street when background more or less is dark in the night. So this means, and here you can see, there is in fact a shift of sensitivity. The photopic vision during the day, which has its maximum at 555 nanometers, and the blue one, the scotopic vision during the night, there is a shift to shorter wavelengths, to 507 nanometers. And as we saw before, at around 500, 507 nanometers, we are talking to the of blue light in the visible, meaning that at night times, at low ambient light levels, we are more sensitive in blue. And of course, what is also happening, what we can see here, what we all know, that the detector itself is adapting to the light level. In our case, for the human eye, the pupil diameter changes and is in fact decreasing the higher the typical ambient light levels are. And this is also important if we take a look at the adaptation of the human eye, because what are we talking about? Adaptation, of course, the adaptation to various ambient light levels. But here, what are the thresholds we are talking about here for the human eye? And in fact, the human eye is capable of adapting to a really high range of brightnesses and ambient light levels. So in fact, a cloudy night sky with no light from the ground means just think of a night sky. You don't have any light pollution, meaning that you don't have any light coming from the ground. Then you normally, if you think about the clear sky, you only have starlight. And if you then have clouds, you don't even have starlight. So it's even darker, this sky. And the human eye is in fact capable of adapting to such low brightness levels. And on the opposite, it can adapt to very, more or less, very high light levels with its maximum at a range or at a value of a normal incandescent light bulb. But in fact, if you think about, okay, yeah, the human eye can adapt to very low brightness levels or dark, very high darkness levels if you want. So why in fact do we have, for example, street lighting if we can adapt to this night sky brightness? And here the question is quickly answered. It's about the adaptation times. The adaptation times, if we go from a bright environment to a dark environment, for example, outside of a house which was illuminated inside, and then we go outside into the night at night time, the eye means or needs 60 to 90 minutes to be fully adapted to the brightness. And on the other side, if we go from a dark to a bright environment, of course, we have much more light and the eye is much quicker adapted. This is happening in half a minute, for example, to be fully adapted. We are talking about full adaptation time. So this is just a very short introduction to light and our human vision, human detector of this light. And now let's come to the main topic of this evening, which is in fact the light pollution. So what in fact is light pollution? Let's start with that. I will give you a few examples. I think, or I guess that many of you will know such examples. One example is if light, for example, street lights are over illuminated, meaning that we have way too much light than we would actually need to illuminate the surface, the specific surface which we actually want to illuminate. Another one is misdirection. You can see the misdirection also in the first image, but here in the second image at the church, for example, you can see it even more, especially for advertisements, for example, or buildings to be illuminated. We can often see that the light sources itself are not really pointing only to the surface to be illuminated, but that the light is also lost into the night sky, for example. And the last thing is if this light has a harmful color or a harmful emission spectrum. What exactly a harmful color means, this is going to be discussed later. So here you can see 3 individual examples of how light pollution can in fact be developed. And if we combine this, we have an image such like this here. Maybe you know this building. This is the Post Tower in Berlin. And here, for example, we have all these 3 individual aspects coming together. And of course, talking about such buildings, I want to come closer back to Vienna. Maybe you know this. I want to give you one example of Vienna. So this is the UNICA building here in Vienna, which is also a very negative example talking about light pollution, especially for us astronomers. Why for us astronomers? Because if you know this building or the location of this building, it is directly located beside the Urania Observatory of Vienna, and is one of the reasons why we can only take a look at a few, very few objects at this observatory. Of course, not only this building is the reason for this, because we are talking about the inner city of Vienna, but it is also one source, of course. But these were only individual sources. Of course, if we take a look at full cities, we have a lot of such individual sources. And the result we get are, in fact, if we observe from the ground, that we have light domes above cities. If we are talking about air pollution or foggy environments, we also have diffuse light over the whole city. And if we take a look, for example, here on the top right of satellite data, for example, just think about it. Satellite data are receiving light from the ground. This is in fact even crazy, because why do we even want to point light to the night sky, to satellites. So in fact, satellites only in general get 10 to 15% of the whole output, light output a city is emitting. So in fact, we can see here from the satellites that it's really crazy how much light is even visible directly on a satellite detector. Talking about transformative change, light pollution is currently a hot topic. Why? Because we have new generation of lighting situations. Maybe you've heard about it. Yeah? For example, street lights are converted to the so-called LEDs, the light emitting diodes. The LEDs are definitely the state-of-the-art technology in lighting illumination for the moment. Have one of the most efficient life efficacies. They are cheap in maintenance. They have a long service life. You can even control the power input. So this means you can dim the light during the night. This was not possible for past generation lamps, for example. And for the very, very first time, there is a free choice of the so-called color temperature. The color temperature, what is in fact the emission spectrum of a lamp. And for the first time, we can really choose the color of our light. Here on the left side, for example, you can see high pressure sodium lamps, past generation lamps, which were also used in Vienna for street lights, for example. And on the right side, you can see LEDs. And on the small image on the right side here, this is even one of the new LEDs which were installed here in Vienna. And this emission spectrum gives us, like I said before, the color temperature or the color of the light. And here you can see that most of the lamps, or even all past generation lamps, do have one color temperature. So this was not able to be changed. And for the LED, for the first time, like I said before, we can really choose a variety of color temperature beginning at 1800 Kelvin. The color temperature is given in Kelvin. And the higher the Kelvin value is, or the higher the color temperature is, the more bluish is the light. At first, you can see it becomes so orange, then yellowish, and then it becomes white or even blue. Clear blue sky even is at a very extreme value of 10,000 Kelvin. And this you can also here see at the light bulbs, for example. And here you can see 4 different spectra of LED. Why, in fact, the color is changing? Of course, because the amount of light in shorter wavelengths also increases with the increasing color temperature. And this is the reason why, in fact, you get also this bluish color for the light then, for example. Yeah, and here you can see 4 examples of emission spectra of different light sources. At first, you can see the sun, which has emissions almost in every wavelength. And then you can see the high pressure sodium lamp, which more or less has its emission in the yellow or orange part of the spectrum. You can see an LED with 4000 Kelvin. So this is an example of an LED with 12,000 Kelvin. Here you always have to say the number as they are changing with the color temperature, where you can see that the blue lights or blue amount of light is increasing. Therefore, the light is much more whitish or bluish compared to the high pressure sodium lamp. And then the last example, maybe you know the metal halide lamps from stadiums, for example, and they also show very sharp emission lines, for example, also in the blue. This is why also you can see here this whitish color. So with this information now, we can go into the impacts of light pollution. Now you are more or less prepared to talk about the impacts, and I want to make these impacts interdisciplinary. And since I'm an astronomer, I want to start with the impacts of light pollution on astronomy. If you think about it, I think it's very easy. And I think this is maybe how you know light pollution. We cannot see very many objects on the night sky. And the higher the night sky brightness is due to artificial light at night, the less the objects we can really see. Here in this image, maybe some of you know it, you can see the night sky over Ontario in Canada, which was captured on the left side during its general state, and on the right side during a blackout in 2003. In 2003 in Canada and in USA, more than 75 million people were affected by a blackout. And this image was taken by an amateur astronomer. and he just wanted to show when all the lights were going out, what the night sky could actually look like. And in fact, the people there, for the first time, some of them saw something like the Milky Way, which you can see here. And this blackout happened in the middle of August. And in the middle of August in the Northern Hemisphere, so also here valid for Vienna, maybe you've seen some of them before, we have a very famous meteor shower, the so-called Perseids. And for the first time there were also some people who for their first time in their lives saw some meteors. But just think about it. If you see a night sky and now suddenly you can see objects moving in the night sky, you can think of something else. And this was also something discussed, maybe UFOs. Yeah. But just think about this. For the first time, people saw moving objects like meteors. Of course, they did not think about meteors, Sternschnuppen in German. Yeah. Really, are these objects or are it UFOs? Yeah. So just to get a feeling what these people actually saw the first time in their life. So talking about a number of, for example, stars, which are visible to the naked eye, you can see here the number of stars plotted to the night sky brightness in zenith. Zenith is the highest point of the night sky, which is more or less quantifying the light pollution for the whole night sky. And here you can see, this is only something I want to go into very quickly, that the night sky brightness has a number called magnitudes, astronomical magnitudes, in fact, which is a logarithmic scale, meaning that between one magnitude, we have a factor of 2.5 of increasing brightness for this night sky. And in fact, these magnitudes are not a value giving you the brightness, but more or less the darkness of the night sky, because if this value decreases, the night sky brightness is increasing. Yeah, so this is in fact a non-logarithmic value, so meaning that you just think about as a value for the darkness of the night sky. And talking about 22 magnitudes, this is one of the holy thresholds for astronomy, because talking about 22 magnitudes in the highest point of the night sky, you can really say that we are talking about an unpolluted sky. And here the human eye would be able to see, valid for the Northern Hemisphere over a whole year, more than 6,000 stars. And to get a feeling, where is Vienna in this plot, for example? Yeah. So we did some measurements at our observatory, the Vienna University Observatory. Maybe some of you know where we are. We are in the 18th district of Vienna at the Türkenschanze near the Aumannplatz. So we are more or less far distanced to the center of Vienna, and we are in fact on the Türkenschanze on a hill, so above all the street lighting for Vienna. But the value is not very good. We are somewhere between 18.5 and 19 magnitudes in general for a clear sky, meaning that here at our observatory, we can only observe up to 300 to 500 of this potential 6,000 stars in the night sky. And if you go further inside of the center, what this looks like on the night sky, here, for example, you can see a more or less only slightly light polluted night sky. You can see some light emitting sources on the horizon, but you can also see the Milky Way. This is located in the National Park Neusiedler Seewinkel in Burgenland in Eastern Austria. And for example, if we do such a measurement, light pollution measurements, only this image does not really say anything about the night sky, but we can develop a so-called light pollution matrix where we can really see where or which night sky brightness values are at which point of this night sky. And here you can see the bluish and the greenish colors here in this matrix. They say that we have a natural night sky there, and the red and the white colors here are in fact the light emitting sources. So here you can really see the light domes, which mostly come from the horizon, of course. And yeah, just think about this. Blue and green colors are a natural night sky. And now let's take a look at the night sky of Vienna at our observatory. This looks like this. And of course, you can see, like we discussed before, only few stars visible. And here you can also say that the exposure time, for example, was not that high, of course. So let's compare this also with the light pollution matrix we have seen before. Just to remember, blue and greenish colors are a natural night sky, but in fact, we don't have such colors here anymore in Vienna. And here you can see a total opposite image. Yeah, this is really crazy how the light pollution is already developed here in Vienna. And in fact, the difference here is at about 3 astronomical magnitudes, which means that the night sky here in Vienna is more than 16 times brighter than measured here at the national park, which is only slightly polluted. Very shortly, only give you some more extreme examples. So for example, if you compare a location here, which was taken near Berlin, I think Ludwigsfelde is nearly 100 kilometers south of Berlin. You can see that the location itself is not that bad, but you can see Berlin, for example, here. And this was taken without any snowy surface. We will discuss later why this is important, and with a clear sky. And talking about clouds again, we were talking about the clouds at a place where we don't have any light coming from the ground, meaning that you don't even have starlight, that the location is even becoming darker, for example. Yeah, and this also means for a light polluted sky, for example, yeah, that the clouds can, at a light polluted sky, even reflect light coming from the ground and also scatter light here, for example, from Berlin. And suddenly Berlin is becoming visible over the half of this night sky or even more. Yeah. And in fact, also the night sky brightness due to this reflection and due to the scattering of the light pollution is also increasing. And in fact, the factor of more than 5 times brighter only due to clouds. And now the third case, when we also include snow, then you have a reflection on the night sky, again, a reflection from the ground. And this is becoming totally crazy because then the night sky suddenly looks like this. And we have a night sky which is 100, nearly 200 times brighter than without any snow or without any clear sky. So here you just should get a feeling how easily light pollution can be increased or developed, in fact, only due to meteorological reasons here. And coming to the most extreme example, maybe I can give you a very good location, like I said before, without more or less any light pollution sources, only one small at the horizon here in Latvia, where you can see a cloudy night sky in Latvia becoming darker. We don't have light pollution sources, becoming even darker due to clouds. And compared to the location here in Germany, in Berlin, with snow and cloudy to a very, very dark overcast sky, then you can see that the sky here in Berlin was even 3,500 times brighter than this natural brightness. So this, in fact, is a natural brightness because we are not impacted by any artificial light, only by clouds, which are also natural. And this is a value which is, of course, absolutely crazy. So talking about astronomy, going beside, now let us talk about wildlife. Yeah. Maybe I want to start with a short video. Maybe some of you have seen the European Championship in football in 2016. I want to give you the short clip here. And in the final between France and Portugal, there was something happening which was not happening at any other game of the European Championships at that time. There were a lot of animals on the field, and the players had a lot of problems with these animals, with the flying animals, they said. And just to give you a short hint here, you can see it. Like I said before, this was only the case for the final. So it had not had anything to do. There was a game even 3 days before in that stadium. And suddenly in the final, there were a lot of insects on the field in the whole stadium. Maybe you saw it. It was a very big topic when I watched it live on TV. And I found one citation online which said thousands of the relatively big insects inhabited the pitch. Some were even talking about millions. And it took only a very short time to know the reason why this was happening and why, in fact, this was happening only for the final, because for security purposes, the stadium light was switched on during the whole night before the game. It was only done for the final. And suddenly you can see, okay, animals are definitely reacting to the light. And you can see here, if you think about that, nearly 70% of all mammals are nocturnal and only 20% are diurnal. Then just think logically, yeah, there is something happening with these animals if we make the night, the natural night, to an artificial day, more or less. And if we take a look even at the evolution of vertebrates, for example, we can see here that that nocturnality was in fact a very profound step with an increasing number of animals becoming nocturnal over the last few 50 to 100 million years. So nocturnality was really a profound step for the evolution of these animals. So in fact, what happens if we displace this natural night? In fact, what is happening? Of course, there is a lot of loss of habitats and wildlife corridors. They are drastically comprised and the animals are fleeing from the light. There is a loss of orientation also for invertebrates, for example. Just think of a light in the garden, for example, a loss of orientation for moths, for example, which are flying into the light and can't find out anymore. A lot of animals, flying animals, have to stay inside of this light because they can't find outside anymore. So they fly, in fact, until they die. And of course, this means different movement behaviors, different foraging behaviors. And all, in total, you can say there is a massive decrease in biomass and light pollution. In fact, if you compare other factors for a decrease in biomass over the last 100 years, for example, of course, you can say that artificial night sky brightness or artificial light at night was one of the constants of this anthropogenic time. And talking about invertebrates here, just to give a very short view, of course, we know that invertebrates and many animals are attracted to light. And here you can see the intensity, how animals react at which wavelength to this light. Of course, biological responses are in fact over all wavelengths, not only the visible light. Animals we know can even see, for example, infrared. So there are a lot of more impacts on these animals. But invertebrate attraction is especially for the shorter wavelengths, so for the blue light. And here you can also see some different spectra of lights again in the background. For example, the LED here, a very bluish LED. But you can see that here for the shorter wavelengths, you can really see that every animal is affected, attracted, affected, whatsoever. So coming from ecology to biology, more or less, or also different, let's take a look at the impact on environment and nature. The environment, as we know it, just take a look at trees and plants, for example. We all know that they are sensitive to sunlight or very high light levels during the day and during the night also. And we all know what the photosynthesis is, what is happening for plants, for example, that oxygen is emitted, carbon dioxide is absorbed, and this all is induced, of course, by the sunlight. And normally, usually in the nighttime, the opposite case is happening. And what we also know is that the photosynthesis is especially induced by light coming also again at shorter wavelengths. Between 420 and 460 nanometers, there is the highest sensibility of plants to undergo the photosynthesis. So just think about now having nighttime, a plant under a street light. Well, what is happening then at night if it still receives light? Of course, it has to undergo the photosynthesis also during the night and maybe also during the winter. And this is something we can even see. Just take a look when you walk through parks of Vienna, for example, where you sometimes still have very bad lighting fixtures. then you can see what is happening with these trees, for example, that you have green leaves over the whole year, even leaves over the whole year, also in winter times. So the tree itself has to undergo the photosynthesis at all times, 24/7 over the whole year. Normally we say, okay, if it has green leaves over the whole year, this is something nice, yeah. But also on the other side, the lifespan of these trees and the plants are drastically reduced by this fact. And now coming to ourselves, what is happening with light pollution? What is happening with us undergoing events or impacts of light pollution? Since we humans are on this beautiful planet, our body or we ourselves, we oriented over a rhythm undergone by the sun, that we have a day and we have a night. And our body concentrated on this rhythm, the so-called circadian rhythm, meaning that it undertakes some certain processes inside of our bodies, like hormone secretion, for example, at certain times, at day or at nighttime. So, for example, you can see that the best coordination is at afternoon, for example. We have blood pressure, which is controlled by the sun or the circadian rhythm. We have the body temperature, which reacts on it. So our whole body reacts to the circadian rhythm, in fact. And this is all done through hormone secretion. And I want to discuss especially two hormones of our body. The first one is cortisol, and the next one is melatonin. So cortisol is a hormone we need to be active during the day and to have a great attentiveness. Here you can see over the day and in the morning, cortisol is rising, is increasing, and then also followed by this cortisol, the attentiveness and activeness of our people is increased over the whole day. And then in green, you can see the melatonin, which is exactly the opposite, which is our sleep hormone, or which we need to get a good rest, to get a good sleep, to be relaxed, and to be attentive and active the next day again. So here you can see that the attentiveness is decreasing with an increasing melatonin, and also the body temperature, of course, like I said before, is reacting on this, to this. With an increasing melatonin, you can see that the body temperature is also decreasing. And what you can see here with the melatonin also, which is a very, very important hormone, I want to check this out again, which is increasing over the nighttime and has its maximum in the night. And is then steeply decreasing until morning times again. And what, in fact, is happening if we do not have a circadian rhythm and if we do not have this hormone secretion of melatonin? And this is easily answered. The direct consequence, of course, if we don't get relaxed, if we don't get a good night's sleep, sleep disorders are the direct consequences. And with the sleep disorders, we have resultant health issues like metabolic disorders, weakness and performance problems, of course. Very important support of lowering blood levels, meaning that we have an increased probability to have breast, prostate, or other cancer types, and some other things like obesity, diabetes, and so on. And for all of this, the stimulating factor can be the melatonin suppression. And why, in fact, is this melatonin suppression now so concentrated here in this talk of light pollution? Because, and this is what I want to show here, like discussed before, our body reacts to light. Our human detectors, our human eye and the brain reacts to the light which is coming. And here, in fact, you can again see the photopic and the scotopic vision, the day vision of the human eye, which is here in white, in the white line. In the black line, you can see here the night vision, the high night sensibility of the human eye. And now focus on this blue line. And this blue line is very important here because this blue line says if light of these wavelengths here reaches our eye, the melatonin is suppressed. Melatonin cannot be secreted anymore because melatonin needs a rest, more or less, of, for example, the pineal gland here in the brain. But if it stays active, especially at these wavelengths here, with the highest sensibility here in the blue, you can see here that the melatonin can be suppressed. So here, especially light at lower wavelengths, like we've seen before for the environment and for the animals too, between 400 and 500 nanometers, is including the melatonin suppression especially. So just to summarize, what we know now is, at first, that the displacement of the natural darkness is, of course, infecting every living being on the planet Earth, and that especially light at lower wavelengths, meaning for the visible blue light, can be dangerous for all organisms here. And therefore, there is a recommendation, for example, for LEDs, for the outdoor situations, to be installed with a color temperature of a maximum of 3000 Kelvin. So if you go into a shop where you can buy LEDs and light bulbs, you can always see that there are warm white ones and cold white ones. And the warm white ones are normally between 2700 and 3000 Kelvin. This is normally the maximum of blue light we want in the outside. So this, in fact, is the recommendation from the light pollution community or researchers here, what we give as a number. And now I want to talk about what is the current state of light pollution. Is it really that bad globally? Is it really that bad here in Austria? So have a look at this world map here. You can see the so-called World Atlas of light pollution or of artificial night sky brightness, where you can see all the places or locations where you have to, which are impacted by light pollution especially. And it is, in my opinion, not a surprise that this is affected for two continents, in fact, at most, North America and Europe. But to give you a few numbers, what this light pollution map you can see here means for us. We know that at the moment, globally, 83% of Earth's population live under skies polluted by artificial light at night, or short ERN. It means only 17% have a pristine night sky. For North America and for Europe, we were just talking about it, it is much worse, because here 99, this is also a crazy number, in fact 99% of the population live under skies polluted by artificial light at night. And if we take a look how the light pollution is developing globally, what is it increasing, is it decreasing? Yeah, I think you know what is the answer here, that the total radiance grows by nearly 2% per year globally. This was measured between 2012 and 2016. And that areas showing illumination by artificial light at night are also growing by even more, slightly more than 2% per year. This is also, again, please think about this, a global value. Thinking about North America and Europe, again, this light growth rate is even worse, with 6 to 7% per year. So this is, in fact, even more steep or steeper in its increase. So what does this mean if we come back, for example, to this chart, which we have seen before? Yeah, just think about this. Okay, 2% per year is maybe not that much, you can think, yeah. But for example, if we go on with this, if we go on with this 2%, or if we go on in Vienna, in Europe, in North America with the 6 or 7% increase per year, this would mean that the global average by 2040 is somewhere around here. Something about 14 to 15 magnitudes. This is the global average. So this means if we talk about the global average for big cities, for city centers, this value is much worse. And this means we can't see the sky anymore. And of course, with this, the impacts are, of course, also increasing. To give you a few feelings about how light pollution really changed and how we think, talking about this 2 and 6% change, how the simulations say that it will change over the next few years. Yeah, you can see here, for example, what happened to North America between the late 1950s and, for example, the simulation which shows how North America will look like in 4 years, in 2025. So compared to the late 1950s, you can see that on the eastern half of North America, you only had places, individual places which were affected by light pollution. And between them, you had good night skies. And this completely changed with the eastern half of North America being completely light polluted and only the western half being slightly or showing areas which are not affected by light pollution. So this simulation really shows what was happening in this anthropogenic era of outdoor lighting development. For Italy, Italy is one of the worst examples in Europe. You can also see here what happened over the last 50 years. And one thing I always say here, if you take a look, for example, at Italy in the late 1990s, and in 2025, also how it will look like in 4 years, you can see that the light domes are even beyond the shore. So you have light domes of city above the sea, even kilometers inside of the sea, so even above or beyond the shore. So this is really crazy. And also, if we take a look at the islands here of Italy, you can see that also here, even the northern island of Italy was not or only slightly affected by light pollution. You can see the islands again, but here you can see that we have more or less one light dome, doesn't matter above the island or above the water. So this is also a crazy development here. Here you can see Milan or Milano, in Italy, also one of the worst examples in light pollution. This is how Milan looked like in 2012. You, of course, were able to see the city or radiances from satellites, of course, But in 2012, they started the lighting conversion to LEDs. This is something I discussed before, to LEDs. Unfortunately, they chose LEDs which were very, very bluish with 4,000 Kelvin color temperature. And this is how it looks today. You can even see the color change the city was undergoing. And in fact, you can see that some glares are now occurring, which were not occurring before. So there was not only an increase in light, but also this light change conversion to more or higher color temperature. So talking about Austria, this is the light pollution map for Austria. Also here, unsurprisingly, you can say that all bigger cities, all capital cities of Austrian provinces do show very high artificial night sky brightness values. You can see here here again, the blue colors are for natural night skies, and the red or orange colors are for the light polluted areas, with the purple one being more or less the sources themselves. And of course, the most polluted area here in Austria is the eastern part with Vienna, not only due to Vienna, but also because of Bratislava, for example. The whole northern Burgenland, for example, shows one big light dome coming from Vienna, Sopron here, and Bratislava. But on the other hand, Austria has one of the darkest skies of Europe, namely here in the Alps, in the middle of the Alps. Of course, we don't have big cities there. We don't have a very developed periphery here. So this is the reason why we still have very good skies here in Austria. And this is also something that has to be said, that here we can even see locations, which is very, very rare or even unable to find in Europe, with areas which are not polluted by light pollution. We see that the radiance, this is also something I want to go through very quickly, that the radiance, which is measured by a satellite, for example, over Austria, that the total radiance is increasing in Austria. We're still waiting for the value of 2020, that we can see maybe some lighting conversions could affect this value to become better, but in fact, the amount of light seems to be steeply increasing. And here, in fact, you can see that from this light pollution world map, that at the night sky, for example, at the value here, this classification of 18.8 magnitudes of sky brightness means that a night adaptation for our eye is even not longer possible. And this affects more than 10% of the population here in Austria, only 0.1% of the area. But this means here we are talking about the inner city of Vienna, in fact. Yeah. And in fact, here, this is also a number I think is very, very sad. For this classification here at 20.2 magnitudes, the Milky Way is no longer visible. And here you can see that, in fact, 1/3 of Austria's population does not see the Milky Way above their heads, in fact, at nighttime. Only 2% of the area, about 1/3 of the population. Also, of course, we are talking about Vienna here, the majority of Vienna here. Vienna itself has a conversion undergoing. I said before that there were some LED lighting changes of street lights, especially of this Hängeseilleuchten in German, are they called. And since now, over the next few months, they finished this 4-year-long process, which started in 2017 with 1/3 of all street lighting points in Vienna being changed. So 50,000 light points are 1/3 of Vienna street light points. And I just want to say that these LEDs, they are in fact a good thing on the one hand, a bad thing on the other hand. Let's say it like this. So on the positive side, you can see that it is fully shielded to the above. So only light is now coming to the ground. You also have the emission beam being concentrated on the street now, for example. But on the negative side, let's say it like this, Vienna also shows, like Milan, that a color temperature of 4,000 Kelvin for their LEDs. So in fact, for Vienna, we have to say that the street lights, the LED street lights, do show an increased part in shorter wavelengths or in the blue light. Here you can see the map of Vienna. All the green points are these LEDs, which are now changed. The blue points are the last points more or less, which will be changed in the future. But now let's think about that. I nearly come to the end of my talk. Let's think about this. Now we have LEDs which are fully shielded, meaning that we no longer have any emission coming to the upper hemisphere. So in fact, if you think about this, now we have 50,000 lighting points which don't have emissions to the upper hemisphere, meaning that the satellite measuring the light pollution should see a decrease in the total radiance or in the average radiance of Vienna. And if you take a look at the satellite values, this is exactly also here the opposite effect. And even if the street light is changed, you can see that we have some other major sources which are impacting the light dome of Vienna or developing the light pollution here in Vienna, which are in fact the illuminated surfaces, buildings, advertisements, and so on. So the last section of my talk, talking about transformative change again. We are talking about the change here on our planet Earth. What can be done in this relatively small issue of light pollution to undergo a transformative change to an environmentally friendly and a sustainable future? What can be done? In fact, we were learning LEDs are a very good point. So for every lighting situation, use LEDs. They are energy efficient. They are really, really good ones. You can shield your light sources. In fact, you have to ask yourself, where should the light be? What should be illuminated? Yeah. For example, if we take a look at street lights, street lights, the name itself says it. What do we want to illuminate? We want to illuminate streets, not buildings on the side, not green areas, not trees whatsoever. So what should really be illuminated? All the time, it should be secured that the upper hemisphere, the night sky, is not affected. We have seen why. Use an environmentally friendly color, meaning no light below 500 nanometers at shorter wavelengths, or also above 680 nanometers, meaning then coming to infrared, for example. There are also light sources which still have some emission lines in the infrared, which is not visible for us, but visible for animals, for example. And for LEDs, this means only use a color temperature of warm white LEDs, being below 3000 Kelvin, actually between 1800 and 3000 Kelvin. Yes, the efficiency of the LEDs is very, very slightly decreasing, also with decreasing color temperature. But here we have to think about what is more important. In fact, it's only a few percentage of change here. You can dim your light, you can switch off unnecessary light. This also has to be said. Very important thing is that the solution for light pollution cannot be to have no light at all. This cannot be done because we need light, of course, for security reasons. But we need the light only there where it is necessary, where it does not glare, for example. This is always the case if it's shielded, if it only illuminates surfaces you want to. And this also is more or less an appeal for industry and advertisements, for example. Do we really need to know at 3 a.m. in the morning that there is a spa, for example, or whatsoever, something else. There are a lot of advertisements. Keep indoor lighting really indoor. There is a lot of light also coming to the natural area through windows, and spread the word. Now you know what is light pollution, how it really affects us, and how a transformative change to a sustainable future can be done in this, like I said, relatively small issue or topic. In fact, if you want to take a look at closer guidelines, more or less, there is an Austrian guideline for outdoor lighting, which is available in German and in English. And this, in fact, you can see online and the governmental website of Vienna and for every other governmental provincial organization here in Austria. And at last, this is my message for you, in fact. Now we were talking about light pollution outside. If you go inside, you can also be impacted by light pollution, which is in fact even worse, because here the light levels are even more increased, are even much higher, of course, because, for example, you can see the images. If we take a look on the phones, on tablets, for example, you have them directly in front of your face, in front of your eyes. So what can you do at home for electrical devices? Here are some tips of mine. Use screens only night shifted. I think the night shift is something that is now installed in every smartphone. But in fact, no screens and no bright lights at least 30 minutes before going to sleep. And lower, if you need some light, lower your light intensity to candlelight in this time. Candlelight is something the human eye can be, relatively good at home. At home, if you use roller shutters, just think about the circadian rhythm. You need sun in the morning. You need the circadian rhythm, even if the sun is rising at 3 a.m. in the morning. I know this is very hard in the summer, maybe, but you are disrupting yourself, your circadian rhythm. But if you need shutters, for example, if you need to shut your windows because of artificial light coming from outside, I can only tell you, go and complain. Normally it works. And this is my very last slide. I want to show you that this Saturday, in fact, there is the Earth Hour between 8:30 p.m. and 9:30 p.m. Unnecessary public lighting should be switched off. This should be a hint for a break for our planet. So if you, for example, have a garden, or if you have artificial light in the outside, just take a look. If you really need this light, take action. In fact, in this Earth Hour, switch it off over this 1 hour, and maybe you see how you can undergo a transformative change towards a sustainable future at your very front door at home. Thank you very much.